Welcome dear students to this program. Today we are going to discuss from class 9 mathematics book chapter 12 Heron's formula. This is part 3. Here we will discuss some more problems on Heron's formula. You see what is Heron's formula? Let us recall it. Heron's formula says area of triangle is square root of s into s minus a into s minus b into s minus c. What is s? S is the semi-perimeter of the triangle. That means it is half of a plus b plus c, where a and b and c are the length of the sides of the triangle. Let's see. Here is the question. A rhombus-shaped field has green grass for 18 cows to graze. If sides of the rhombus is 30 meter and its longer diagonal is 48 meter, how much area of grass field will each cow be getting? You see, let's draw the rhombus. Say A, B, C, D. Each equal side is 30 meter. And the longer side BD is 48 meter. Here this diagonal divides the rhombus into two equal halves, equal triangles. So if we can find the area of one triangle, then by multiplying that area into 2, we can get the area of this rhombus. Let's consider triangle ABD. Here, if we assign the sides as A, B and C, so we can write A equal to 30, B equal to 30 and C equal to 48. This is, all these are in meters. So what is the semi-perimeter? S is equal to 30 plus 30 plus 48 divided by 2, that gives 108 by 2, that is 54 meter. Now what is the area of the triangle? The area of triangle is area of the triangle is equal to square root of s into s minus a into s minus b into s minus c, which is equal to, now let's substitute the value of these s, a, b and c, that is 54 into 54 minus 30 into 54 minus 30 into 54 minus 48. This gives 54 into 54 minus 30 gives 24, again 24, and 54 minus 48 gives 6. Now see, this 54 can be written as 3 into 3 into 6. As here one 6 is there, we can take this as 6. Then 24 into 24 into 6. Now by taking, for a pair of numbers, we can take 1 for square root. So in place of 2 3's, we can take 1 3. In place of 2 6, we can take 1 6. And also we can have 24. So product of these gives 432 meter square. So this is the area of the one triangle. So what is the area of the rhombus? So area of the rhombus is equal to 2 into area of the triangle. That means 2 into 432, that gives 864 meter square. So now the field is of area 864 meter square, and in this field 18 cows are grazing. So for 18 cows, area of grazing is 864 meter square. So what is the area each cow will get? So each cow will graze in 864 divided by 18, that gives 48 meter square. That means out of those 18 cows, we have only, for each cow, we have 48 meter square for grazing. Let's have another question. This question says, an umbrella is made by stitching 10 triangular pieces of cloth of 2 different colors, each piece measuring 20 centimeter, 50 centimeter and 50 centimeter. That means these 3 sides of the triangle are 20 centimeter, 50 centimeter and 50 centimeter. How much cloth of each color is required for the umbrella? So let's see. We have 10 pieces of colored cloths. That means that are of 2 colors. So each color are of 5 pieces. So we need to find the area of these 5 pieces. So this is the dimension of the cloth, 50 centimeter, 50 centimeter, and here it is 20 centimeter. In this figure, we have 3 sides of a triangle. So to find the area, we can apply the Heron's formula. In this case, say A equal to 50 centimeter, B equal to 50 centimeter, and C equal to 20 centimeter. Then what is S? S equal to 50 plus 50 plus 20 by 2, that gives 120 by 2, that is 60 centimeter. So what is the area? Area of the triangle is equal to square root of S into S minus A into S minus B into S minus C, that is square root of 60 into 60 minus 50 into 60 minus 50 into 60 minus 20. So from this we get square root of 60 into 60 minus 50, that is 10, into 10 into 60 minus 20, that is 40. So as we have multiples of 10 here, so we can write like this. 60 can be written as 10 into 6, then 10 into 10, and 40 can be written as 10 into 2 into 2. So, for taking the square root, we can take 10 into 10 into 2 into root 6, which is equal to 200 into, and approximate value of root 6 is 2.45. So, we can take this is as 490 centimeter square. So, area of each piece is 490 centimeter square. So, area of cloths of each color is equal to this 490, and each color are of 5 pieces. So 490 into 5, that gives 2450 centimeter square. Thus, we can find the value of the area of the cloth, or how much cloth of each color is required for the umbrella. Now let's have another question. See, we have a design here, a floral design. In this given figure, each triangular shape has dimension 28 centimeter, 9 centimeter and 35 centimeter. Find the area of the floral design. Let's see, the design of each triangle is like this, where this one is of 35 centimeter, this is of 9 centimeter, and this part is of 28 centimeter. So this completes the floral design, one petal of the floral design. Now see, if we can find the area of this triangle by multiplying with 2, we can get the area of this petal. Now you see, let's name it as ABC. In triangle ABC, small a is equal to 35 centimeter, B is equal to 9 centimeter, and C equal to 28 centimeter. Then what is the semi-perimeter of the triangle? That means S is equal to 35 plus 9 plus 28 by 2. That gives, this is 72 by 2, that is 36. Now we can apply the Heron's formula to find the area of this triangle. So area of triangle ABC is equal to square root of S into S minus A into S minus B into S minus C. Now if we apply the values here, we have 36 into 36 minus 35 into 36 minus 9 into 36 minus 28. You see, this is equal to square root of 36 into 1 into 36 minus 9 gives 27, and 36 minus 28 gives 8. This is equal to square root of 36 can be written as 6 into 6, and 27 can be written as 3 into 3 into 3, and 8 can be written as 2 into 2 into 2. From this we can have 1 6, 1 3, 1 2, and rest is 1 3 and 1 2 will remain. So we can take as root 6. This is equal to 36 into, in place of root 6 we can substitute the approximate value of it, that is 2.45, that gives 88.2, this much centimeter square. Now we have two such triangles, so area of each petal is equal to 88.2 into 2, that is 176.4 centimeter square. And in our question we have 8 petals, so area of floral design is equal to 176.4 into 8, that gives 1411.2 centimeter square. So the area of the floral design is 1411.2 centimeter squares. Dear students, let's have another question. This question says two sides of a quadrilateral are 15 centimeter and 8 centimeter respectively. Angle between these two sides is 90 degree. If length of the other two sides are 17 centimeter, find the area of the quadrilateral. See, in this quadrilateral we have two sides perpendicular to each other and two other sides which are equal in length. So we can say A, B, C, D, out of which the sides AB and BC are of 15 centimeter and of 8 centimeter, and other two equal sides are of 17 centimeter. Now if we join AC, we have a right angle triangle. So out of this right angle triangle we can find the area, we can find the hypotenuse, that is AC. AC is equal to square root of AB square plus BC square, that gives square root of 15 square plus 8 square, that means 15 square is 225 and 8 square is 64. This gives square root of 289, which is equal to 17 centimeter. So we can write AC as 17 centimeter. Now this quadrilateral is divided into two parts. One is of a triangle with each side at 17 centimeter. So we can say triangle ADC is equilateral triangle. As each side is known, we can apply the Heron's formula, but as we know this is an equilateral triangle, we can directly put the formula to find the area of equilateral triangle. That is, area of triangle ADC is equal to root 3 by 4 into each side, area of square of each side, that is 17 square. This gives root 3 by 4. In place of root 3 we can write 1.73 by 4, and 17 square is 289. This gives the value as 125.14 centimeter square. And what is the area of triangle ABC? Here also, as all the three sides are known, we can apply Heron's formula, but as this is a right angle triangle and AB and BC are the adjacent sides to the right angle, we can put the formula half base into height, that is area of triangle ABC is equal to half into BC into AB, that is 1 by 2 into 8 into BC, AB is 15, that gives 60 centimeter square. So area of quadrilateral is area of quadrilateral is 125.14 centimeter square plus 60 centimeter square, that gives 185.14 centimeter square. Thus, the area of this quadrilateral is 185.14 centimeter square. Let's have another question. This question says the length of two parallel lines of a trapezium are 54 centimeter and 30 centimeter respectively, and length of each of the non-parallel lines is 20 centimeter. Find the area of the trapezium. Let's have the trapezium. A, B, C, D, where AB and CD are equal, that is of 20 centimeter. And AD, the parallel lines are of dimension 30 centimeter and this is 54 centimeter. BC is 54 centimeter. Let's draw a line through D which is parallel to AB. AB is parallel to, say, DE. Now in ADEB, AD is parallel to BE and AB is parallel to DE. That means ADEB is a parallelogram. If ADEB is a parallelogram, this shows that AB is equal to DE is equal to 20 centimeter and AD is equal to BE is equal to 30 centimeter. If BE is 30 centimeter, then what is EC? EC is equal to BC minus BE, that gives 54 minus 30, that is 24 centimeter. So we have EC as 24 centimeter and DE as 20 centimeter. Now let's find the area of this triangle. So for triangle DEC, A equal to 20, B equal to 20 and C equal to 24. All these are in centimeters. So what is S? What is S? That is semi-perimeter. Semi-perimeter is equal to this 20 plus 20 plus 24 by 2, that is 64 by 2 gives 32. Then what is the area of triangle DEC? Area of triangle DEC is equal to square root of S into S minus A, that means 32 minus 20 into S minus B, that is 32 minus 20, and S minus C, that is 32 minus 24. This gives square root of 32 into 12 into 12, and here it is 8. Now, as here it is 32 and 8 is there, so we can split this as 2 into 2 into 8. Then we have 12 into 12 and into 8. So by taking 1 2 for 2 2's, we have 2. Similarly, we have 1 8 and we have 1 12. And this gives the value 192 centimeter square. So area of this triangle DEC is 192. To find the area of the trapezium, we need the height of the trapezium, that is same as the height of the triangle. So we can say that is area of triangle DEC is equal to, say, if this height is, say, DF, that is H, we can write half into height into base is 24, and this area is same as 192. This gives height is equal to 192 into 2 by 24, that gives 16. So height is 16 centimeter. As height is 16 centimeter, let's see the area of trapezium is equal to half into height, that is 16, into sum of the parallel sides, and sum of the parallel sides we can write 3 plus 54, that is equal to, this gives 8, so 8 into 84 is equal to 672 centimeter square. So area of this trapezium is 672 centimeter. Here also, to find the height of the trapezium, we use the area formula of the triangle. So the Heron formula is used here. Dear students, today we discussed about the application of Heron's formula, how to find the area of the trapezium. To get the height of the trapezium, we used the Heron's formula, and also to solve some more problems, we used Heron formula. So the Heron formula is to find the area of the triangle when 3 sides are given. Today we close here. Thank you.